Hello, everybody. It's me again, Rich Andre, and today we're going to be talking about enzymes. Okay, so this is going to be the third part of my biochemistry sort of like uh topics that I discussed earlier or the other days, which were about metabolism, catabolism, anabolism, and also the four essential biological molecules, which are carbohydrates, lipids, proteins, nucleic acids. So today we're going to be talking about enzymes. So what are enzymes first? Let's first define enzymes. Enzymes are basically just this sort of like substance that you have all over your body that basically sort of like speeds up the chemical reactions that happen inside your body that are sort of essential to maintain the processes that happen in order to sustain your life, in order to sustain your overall well-being and just life in general. So these enzymes, okay, they help to sort of like facilitate the chemical reactions that happen in order for us to breathe, in order for us to build muscle, and also to clear out toxins in our body. Like, for example, in the liver, we have a sort of like enzyme. I forgot what it was, but we have an enzyme in the liver that basically gets rid of the toxins in our body. Just like for alcohol, for example, it is basically a process of detoxing in the liver. So you start with the toxin, and then apparently it converts to water, and eventually it'll be eliminated. And this last part says here is the expulsion of water-soluble metabolites. So metabolites are any substances that basically are a part of your metabolism, like carbohydrates or such and such. So here's the structure of an enzyme. Here you have the protein structure, which is basically just this outer part. And then it says here this is the binding site and the catalytic site, or the active site in general. And this is where, and this little hole right here, this black hole right here, is where what we call the substrates are located, okay, or are going to be binded in. That's why it's called the binding site, okay? So substrates are basically just this place where enzymes do their work, okay? So enzymes basically, they bind onto these specific substrates. As you can see here, it binds into these specific like substrates, and there are many types of these, okay? There are many types of substrates and enzymes, but generally speaking, this is how they work. We have an enzyme, and this is the active site of the enzyme, and this is where the substrate is going to be placed. And typically, the lines, okay, the outer lines are exactly the shape of the substrate in order for them to fit once they eventually evolve or turn into this enzyme substrate complex. And this is going to be a hole, okay? And that is where the chemical reactions happen, I believe, okay? So what are the examples of enzymes? If you can see here, we have proteins, carbohydrates, lipids. So these are three of the four essential biomolecules. And these proteases, I don't know if I'm butchering the pronunciation of that, but proteases, carbohydrates, or lipases. Okay, I know it's lipase, carbohydrates, and protease. These are basically the enzymes that break down these larger biomolecules, these proteins, carbohydrates, lipids that you basically consume from your food, from the food that you eat, in these sort of like building blocks or monomers, which are amino acids, simple sugars, fatty acids, glycerol, so on and so forth. So that's basically one of the examples of the uses of enzymes in terms of digestion. Okay, these are the three enzymes that are sort of like a catalyst, or sort of like pioneers for the day-to-day digestion that you're probably not aware of. Okay, so thank these three for your digestion, for your ability to digest the food that you eat. Okay, so one thing that we have to know is, what is the pH? So pH, well, pH and temperatures affect on enzymes. So these two aspects, okay? So pH stands for potential for hydrogen, okay? Potential for hydrogen, and temperatures effects on enzyme. What are those effects? There are a lot, of course. There are a lot of effects on enzymes, but two notable effects of these two aspects, pH and temperature, on enzymes is, first, okay, if you can look at a pH scale here, you can see the acids here from 0 to 7, okay? These are very much acidic, okay? But it gets more and more acidic as it gets to red, as it gets to the lower end, okay? Lower left side of the pH scale. It says here the stomach acid, okay, is the most acidic. It's one of the most acidic sort of like substances in the pH scale. And there's a reason for that. There's a reason for why stomach acid is the way it is. That is because, let's say, if you don't have enough acid in your stomach, okay, this thing that we call pepsin, this pepsin basically just sort of breaks down proteins in your stomach in order for you to digest food, okay? And if you had, okay, if your stomach wasn't as acidic as it is in the pH scale here, okay, or if there's not enough acid in your stomach, then pepsin is not going to work as well as it's supposed to, or not at the optimum levels. Okay, so that's the role of pH when it comes to the effectivity of enzymes, okay, like pepsin, as we just have discussed. Okay, so what is the role on temperature? What is the role of temperature on enzymes? The effectivity of enzymes. We suppose we have a person who has a high fever. Okay? Now, when you have a high fever, most likely or not, you're going to be a little bit indigested, or you don't have much of an appetite at all. To be more specific, okay? And that's because enzymes rely on temperature, okay? They at the most optimal sort of temperature that enzymes operate at is the normal temperature of 37 degrees Celsius, okay? 37 degrees Celsius body temperature. Anything higher than that, and certain enzymes, okay, are just not going to work. They're not going to work as effectively as they would during normal body temperatures, okay? So that's basically sort of like an overview of enzymes.